Okay. Bismillahirrahmanirrahim. So this is 2021, May, June, UP, 4, 3, mechanics, and I was here in Skoda 2 days later. Question number, let's go through the whole question first, whole paper first, sorry, that we know what kind of questions we are going to face soon, inshallah. So, two possible values of speed. So, this is a basic momentum question. Then we have the mass of the cyclist, energy, work, power, similar to that. Now we have the forces question, equilibrium. Then we have kinematics. And we have another work energy question. Then we have again equations of motion. And then at the end we have the friction. And that's only 7 questions. Okay. If that's the highest number of questions, sometimes we get 6, sometimes we get 7. So the particles P of mass 0.4 kg and 0.5 kg are free to move on a smooth horizontal plane. P and Q are moving directly towards each other with speeds 2.5 meters per second, 1.5 meters per second, respectively. After P and Q collide, the speed of Q is twice the speed of P. Find this two possible values of the speed of P after the collision. Okay, so basically, try to make as many like diagrams as possible, like so you can visually imagine what the whole scenario is like playing out. So we have two particles, P and Q. Let's call this P. Let's call this Q. So they're basically heading towards each other in different speeds. And since it's a smooth horizontal plane, that means there is no friction, so the speed is constant throughout the whole plane. So they've given us initial speeds, and then they're asking us to find the final speed of P. Okay, so and the most important information in this question we have is that the speed of Q is twice the speed of P. So and that means the two possible values, let's say, like so for case one is uh that the speed of, let's say, speed of Q is 2v and speed of P is v. Okay, like the initial final velocity after period of speed of Q is twice the speed of P. Okay, so we know that the equation or conservation of momentum means that the initial momentum is equal to the final momentum. Initial mass is 0 of P. Let's take 1 as P for 0.4 kg. Initial speed is 2.5 plus the mass of Q is 0.5 kg. And its velocity, it's since we took 2.5 as positive, so we'll take 1.5 as negative since it's in the opposite direction. Then final velocity of P has a mass of 0.4 and we took that as v. And final velocity of Q 0.5 to v. Okay, simplify this. 0.4 into 2.4 equals 1. 1 is 0.75 is equal to 0.4v plus v. Five. Okay. So they've asked us to find two possible values, right? So and they said that this since q will always have twice the speed of p. So the two scenarios which we can get is that either p bounces back and q it bounces this way, like they both go in opposite directions, or the other case scenario is that p and q they both like travel still travel in the same direction. So in this case scenario, we're seeing that both are going in the same direction since this is positive and this is also positive. So we were getting here is 0.179 meters per second. And so for the other case scenario, it will be, uh, let's say that P, it goes in the opposite direction. So we'll take 0.4 and negative V plus 1V. So 0.25 gets us 0.6V. So we get is a second. Yep. So these are the two possible scenarios. Basically, uh, these are the only two possible cases, right? Like either B bounces back or B they both travel in the same direction. So these are two. So that's how I find the two possible values of speed of P after the collision. Okay. Question two: a cyclist is traveling along a straight horizontal road. He is working at a constant rate of 150 watts. So they've given us the power of the cyclist at an instant when her speed is 4 meters per second. Her acceleration is 0.25 meters per second squared. The resistance to motion is 30 Newton. Find the total mass of the cyclist and her bicycle. So, we know we have the acceleration, and they've talked about forces, resistance, and they get us power from power. We know we can find the driving force. So, find the total mass. We know that mass, most relative, appropriate equation to find mass would be F is equal to ma. And they've given us the acceleration and resultant force. They've also like almost given us. We need to calculate this from the information which we have. So given us the power, which is 150 watt, and at an instant they've given us speed as well. So we know that power is basically equal to work done over time, which is equal to work done is equal to force into distance over time. Let's make this separately. Then distance over time is basically the velocity. So from here we can derive that power is also equal to the driving force into its velocity. And they've given us the power, they've given us the velocity, this 4, and from here we can find the driving force. So driving force we get is 7.5 Newton. So basically the scenario is something like this. This is a cyclist. Okay, the person over here. So and their uh, apologies for my drawing. And they have a driving force of 20 Newton. So it is 7.5 Newton. And then they have a resistance of 20 Newton. So the resultant force will be 37.5 minus 20 is equal to mass into acceleration from F is equal to ma. So m we get is 17.5, 0.25. Total mass of the cyclist is 70 kg. You understand? Okay. Hopefully, inshallah. Cyclist comes to a straight hill inclined at an angle theta of the horizontal. She ascends the hill at constant speed, 3 meters per second. Okay, so this term is important, constant. She continues to work at the same rate as before. Okay, so you have two important information. Rate is basically power, like burden over time, right? So rate of power as before, and the resistance force is unchanged. Obviously, they've given us a lot of information to know that power is still same rate, i.e. it's 150 watt, and speed is constant. That means that resulting force is equal to zero. We is 33 meters per second, and the resistive force resistance is again 20 since it says it's unchanged. Find the value of theta. So let's uh, sketch our scenario. So let's say this is theta, and I don't want to draw the bicycle again. Something like uh, uh, so uh, let's find the driving force first. We know that P is equal to FP. P is 150. So F we need to calculate, and velocity we have 3. The driving force is basically 50 Newton. So it's getting a driving force 50 Newton. And we know that it has a resistive force of 20 Newton. And the other added force now, since it's inclined, will be the component of its weight, which is mg sine theta. So we know that since the cyclist is traveling at constant speed, so the forward force will be equal to the backward force since there is no resulting force. So we can do is we can equate 50, which is the driving force, with the resistance and the component of weight mg sine theta. Sine theta, since let's say this is a right angle triangle, then this angle is 90 minus theta, right? No, let's say this is another right angle triangle. So say if this is 90 minus theta, then this will be theta. And then this will be sine theta, this component. So 50 minus 20. Mass is 70, which we calculated initially. Gravity is 10. And into sine theta. So theta we get is 30 over 700 sine inverse. So is 0.45 degrees. And since we take angle to one decimal place, we get 2.5 degrees. Okay. Next question, forces. Okay. So for coplanar forces, I like they're acting in the same plane. No three-dimensional stuff going on here. Magnitudes of the forces are 20, 30, 40, and F. The directions of the forces are as shown in the diagram, where sine alpha is 0.2. Okay. So they've given us this. Basically, alpha is equal to shift sine 0.28. And beta, sine beta, is equal to 0.6. So I beta is equal to inverse of sine 0.6. Given that the forces are in equilibrium, find F and theta. Okay. So, like, there aren't, this question is meant very difficult since there is only one way to solve it. That is, resolute all the forces in two directions, vertical and horizontal. So let's find the resulting horizontal first. We know it will be, since these two will, the horizontal component of these two forces will be equal to the horizontal component of these two forces since they're in opposite direction. So 20 cos 60 plus 30 cos alpha. What was alpha? Let's write alpha initially. Equal to f cos theta plus 40 cos beta. Because this is the first equation. Second equation, this is solve it vertically. We know that 20 sine 60 plus f sine theta will be equal to 30 sine alpha plus 40 sine beta. Now all we need to do is resolve solve these equations simultaneously. So like what I like to do is like isolate cos theta and sin theta, then divide the whole two equations to get tan theta, and then that is uh, pretty quick. But I don't know if it's accepted in paper or not. Just for the simple way. You know that f cos theta is equal to 20 cos 60 plus 30 cos, what was the value of cos? Sine inverse of 0.28 minus 40 cos beta, which is sine inverse of 0.6. So let's just calculate f cos theta. So f cos theta, which I am getting, is 6.8. Similarly, f sine theta is equal to 30 sine alpha, which is 0.28, plus 40 sine beta, which is 0.6, minus 20 sine 60. Just calculate this. Okay, so this we get is 15.0795. So if there is a value with like a lot of decimal places, try to take it as close to 4 decimal places. That gives always gives the most accurate value. So if we we know f cos alpha is 6.8. So if we divide these two equations, or let's not divide, let's say that f is basically equal to 6.8 over cos theta. This is 3, and let's call this one 4. So now 3 and 4 will give us 6.8 over cos theta sine theta equal to 15.0795. That means that tan theta will be equal to 5 over 6.8. So theta is tan inverse 2.2176. Theta we get is 65.7273 degree, which is approximately 65.7 degrees. And you know that f was 6 point over cos theta. So f becomes 6.8 over cos 65.7273. So f we have is 16.5 न्यूटन। समझ आई? पर अब इसी से और काम मिला, थोड़ा सा लेंथी होता है। Okay, question number 4. A particle is projected vertically upwards with speed q meters per second from a point on horizontal ground. For 2 seconds, the height of the particle above the ground is 24 meter. Show that u is equal to 22. Okay, it's very simple. So we know this is the ground, this is a particle projected with initial speed of u meters per second. And after, let's say, 1 minute, it's 24 meter. It reaches a height of 24 meter in t is equal to 2. Okay, so just like sketch the scenario or what the information they told us. So the initial speed of u and it covers 24 meter of height and t is equal to 2. So uh, know that equation of motion s is equal to ut half a t square. Since we have since we have t and we have a, so we have t and we have s, we only need to find u. So we get 24 is equal to u, t which is 2 plus half a which is negative 10. Since I discovered in this direction and the acceleration is in this direction, half it is square, sorry, square. So 24 is equal to u, so it's this minus 20, 2u is equal to 44, 2 we get is 22 meters square second. Okay, now the height of the particle above the ground is more than h meter for a period of 3.6 seconds. Find h. Okay, so basically, uh, let's think of the scenario as this. This is you projected vertically upwards, so let's say this is its path, which is not, in fact, it's this, but I'm taking that just to explain. If its path is this, and so, okay, first we need to know that the time it takes to reach a maximum height is the same time it will take to reach ground again. The time it takes to reach maximum height will be equal to the same time it reaches ground. You can test that by using made up values, and that holds true always. So that means that the time it takes, if the acceleration is constant, to travel upwards is the same time it will take to come downwards. So if it was projected upwards with speed of 22 meters per second, and let's say it goes to maximum height, and then it comes back. So it says that the height of the particle above the ground is more than h meter for a period of 3.6 seconds. That means let's say if this is h and it's above this for more than 3 seconds, that means it's going to travel 1.8 seconds from here to here and 1.8 seconds from here to here. So that's how it will be more than 8 for more than 3.6 seconds. So all we need to know is to find h, we can find the maximum height. Okay. And then from there we can find, or we can find the time it takes to reach maximum height. And from that we can subtract 1.8 to find the time it takes to reach h. Then we can substitute that into the equation of motion. So let's say uh, t is equal to u plus at. The final velocity is 0, initial velocity is 22, and our acceleration is negative 10t. So 10t is 22, so t is equal to 2.2. So basically takes 2.2 seconds to reach maximum height. And if you subtract 1.8 seconds from 2.2, you get 0.4 seconds. So that's how much it takes to reach h, right? So now all we do is we put 0.4 into the equation of motion, which is ut plus half at square. So we get s is equal to 8. Basically, h is equal to 8. Tell me if you understood this question, please kindly. The height of the first part is not used in the second part. Uh, yeah, not necessarily, because the height of the first part is basically it just gave us that the height of the particle above the ground is 24 meter after 2 seconds. That doesn't like really help us. So that was just to give us the okay. So let me explain again. So basically, we know that if any object is projected upwards at some initial speed, and let's say it reaches max velocity, max height at t is equal to, it takes 5 seconds to reach maximum velocity. So it will take the same time to reach ground. I think I explained it to someone. I'll have it situation somewhere. Yep. Okay. Think of this scenario. This is the same particle, and its initial velocity is 10 meters per second, right? So the time to reach maximum height will be v is equal to u plus at, 0 final velocity, 10 initial velocity, and negative 10 is the acceleration. It took 1 second to reach maximum height. Okay. So now we find what is the maximum height. So it took 1 second. So now we put it in the, it's equal to ut, and then we get it. Maximum height is basically 5 meters in this scenario. So we know that it took 5 seconds to reach maximum height, and it's 5 meters above ground. So how long will it take to reach ground again? So time to reach ground will be, no, it's the distance between the ground and the maximum height is 5. Initial velocity is 0, since it had instantaneous rest when it reaches maximum height. And t, which is what we need to calculate, half 80 square. Since it's going downwards and the direction is downwards, so we'll take 10 as positive, since that's the direction of the acceleration, t squared. So we get 5t squared is equal to 5, t squared is equal to 1, t is equal to 1. Basically, this is how we prove uh, that the time it takes to reach a point above is the same time it takes to reach the same height covers, same distance it covers to downwards. So if it's maximum height, the time it takes to reach maximum height will be the same time it takes to reach ground from that maximum height. So do you understand this point? So this is very crucial to understand. Okay, so then if we like realize that that is true, That means that if we project it downwards, and the question says that the height of the particle of the ground is more than h meter for a period of 3.6 seconds. So if you like imagine, how can it be more than 3.6 seconds if only like the time it takes to reach maximum height is 2.2 seconds? So how can it be above a specific height for more than 3.6 seconds? That's only possible if if we divide that time, we also consider the time it takes to return to the ground. So basically, that means that so if 2.2 seconds to reach, it takes 2.2 seconds to come back. That gives us total of 4.4 seconds. So, uh, so if we take let's say the ball is here at H, so it is 3.6 seconds above H. That means that it's 1.8 seconds. It takes 1.8 seconds to reach maximum height, and then again it takes 1.8 seconds to reach H again. That's how it will be above H for a period of 3.6 seconds. So that's the main crucial concept over here. How will we find it? Do you understand this point right here? Like how H is 3.6 seconds above H. Okay. So now it's just like simple. You know that the time it takes to reach maximum height is 2.2 seconds, and the time it is above H is 1.8 seconds. Basically, the time it will take to reach H will be 2.2 minus 1.8, which will be 0.4 seconds. So if it takes 0.4 seconds to reach H, we know the initial velocity and we know the acceleration. So we can just use s is equal to ut plus half at squared. U is 22, time is 0.4, and then acceleration times squared. So s we get is 8. We see this distance right here is 8 meter. Understand how we got H? Okay. uh, Question number 5. A car of mass 1400 kg is towing a trailer of mass 500 kg down a straight hill inclined at an angle of 5 degrees the horizontal. The car and trailer are connected by a light rigid tow bar. At the top of the hill, the speed of the car and trailer is 20 meters per second. At the bottom of the hill, the speed is 30 meters per second. It is given that as the car and trailer descend the hill, the engine of the car does 150,000 joules of work, and there are no resistive forces. Find the length of the hill. Okay, so let's sketch the scenario. It's basically towing a trailer of mass down a straight hill, right? So of inclined angle of 5 degree. So this is the hill, angle 5 degree. Let's say this is the car. A beautiful car. And oh, sorry. And this is the trailer. And they've given us their masses. So at the top of the hill, so their total speed is 20 meters per second. But and at the bottom of the hill, their speed is 30 meters per second. So uh so we know that the initial and final, yep, that is the car. The beautiful car. The window. Okay, so so they've given us the initial and final velocities. So we can find the change in kinetic energy from that, right? And they've given us the work done of the driving force as well. Yep, exactly. We can use an energy method, right? We will use the energy method. So we know that the change in energy is equal to change in work done, right? So the change in energy is, let's say, This is h. The vertical distance it travels is downwards. So basically, this is what we need to calculate to find this distance. We can find this x. We still need x, right? So if we know h, we can use trigonometry. So from the energy equation, we can find h. We know that it has some gravitational potential energy over here since it's at the top of the hill. So what is that gravitational potential energy? And since it is decreasing, right? So if when it will reach down the hill, there will be no more gravitational potential energy. So it's basically lost that gravitational potential energy. So we will subtract the gravitational potential energy minus m mass of the system, which is 1400 plus 500, both the car and the trailer, into gravity, 10 into h, which is what we need to calculate, plus I think we'll lose space over here. Plus the change in gravitational energy. We can figure it out since its speed increasing, so its gravitational energy is increasing half m. We can add both of them separately, but it will be easier to just take the masses and half common and then add both speeds separately. 30 square minus 20 square. Final kinetic energy minus initial kinetic energy is equal to 150,000 joules of work done minus resistive for work done against resistive force, which is 0. So from over here, we should be easily able to calculate it. It gives us uh, negative 19,000 H plus four seven five 0. So negative 190,000. So H will be equal to 50,000 minus 475,000 is a negative 325,000. Negative cancels out. So H we get 325, 119. So from over here, which we do initially, we know that sine 5 will be equal to h over x. So basically what we need to find, x is equal to h divided by sine 5. So x we get is 196.2609 meter, which is approximately to three significant figures, 196 meter. समझ आई बॉयज अफनान किस तरह किया ये
हाँ,
इब्राहिम ओके अलहमदुलिल्लाह बॉयज ब्रो आपको आई
yeah, I will end that. Thank you.
is given instead that there is a resistive force of 100 Newton on the trailer. The length of the hill is 200 meter, and the acceleration of the car and trailer is constant. Uh, yep, but we don't need the vertical height, right? We need the slanted height. See, it's basically this, right? This is the hill, and we calculated h and with the hypotenuse x. and this is 5. So basically sine, let's say this is theta, right? Sine theta is basically h over x, right, perpendicular to hypotenuse. Let's call this p, let's call this hypotenuse. And basically, yeah, we're looking for the standard since they asked us to find the length of the hill. This over here, not the height of. If they asked us to find the height of the hill, that would be h. But they've asked us to find the length of the hill. That's why we need to find the slanted height, not the actual vertical height. Since the slanted, basically need to cover the length is basically the distance the system covered, right? Okay. Acceleration of the car and trailer is constant. Find the tension in the tow bar between the car and the trailer. Okay. So first let's find the acceleration. Let's draw or let's take this system. Basically what they've added is they've told us that it has a resistive force of 100 Newton. 100 Newton, right? Okay. On the trailer. So now let's see what other forces do we have. We have the component of weights of this car, which is 1400 G sine theta sine phi. We have the um we have the component of the trailer 500 G sine phi, and then we have tension, which is this. So basically the engine, the work done, it was in part A. So basically it does not mention any driving force in this part. Yeah, tension always faces each other since that's pulling. So it will, if we take the tension in the whole system, so they both will cancel out. So we know that let's find the acceleration. 1400 into 10 into sine 5 plus 500. That's the weight mass of the trailer into 10 sine 5 minus the resistive force on the trailer. It's 100. Is equal to mass into acceleration, mass of the whole system. Let's calculate this quickly. Wait. That is okay. That's smaller. We have the initial and the final speed, right? And we have the length as well. So why don't we just use the equation of motion? Why didn't I get that? So we know that 2a is equal to v square minus u square. Yeah, we can do that, but I find that like finding acceleration from the whole system and then using this single equation from either the trailer and car is basically a quicker method. Since then you don't need to solve simultaneously. Just get acceleration in the first equation, boom, and then you can find tension from the second equation. So it's, I think, a quicker way to find the whole system. Because if you take the whole system, then the tension cancels out. So basically there is no simultaneous equation to solve. So acceleration is equal to v square, which is 30 square, minus 20 square over 200. The acceleration we get 1.25. So we know the acceleration. So now let's take the trailer. Isolate the trailer. The forces acting on the trailer are basically its resistive force and tension on the tension of the spring and its component of weight. So you can say that the tension plus its component of weight minus the resistive force is basically equal to mass into its acceleration. So from here, T we get is basically 49 Newton. Understand? Okay, yeah. They've given us the final initial and distance, so we could have found acceleration from there. That's why I was a bit confused that they haven't given us any driving force, because we really don't need it to know any driving force actually. Okay, question number 5 is complete. I'm going to question number 6. A particle moves in a straight line and passes through the point A at time t is equals to 0. The velocity of the particle at time t seconds after leaving A is. So they've given us the expression of velocity. Find the times at which the particle is instantaneously at rest. Hence, or otherwise, find the minimum velocity of the particle. Okay. So instantaneously at rest, that means v is equal to 0. Let's put v is equal to 0. 2t square minus 5t plus 3 is equal to 0. Get a quadratic is equal to minus t plus minus t square minus 4ac 2a. We get is this instantaneously at rest at 1.5 and 1. So we found when it's at instantaneously at rest. So now to find the minimum velocity, no, it's an upward opening quadratic graph, right? So it's the minimum velocity, and at that point, at its minimum, its gradient by acceleration will be equal to 0. So if we find the acceleration 4t minus 5, which is dv dt, then you put 4t minus 5 equals to 0, we get t is equal to 5 over 4 or 1.25, right? 1.25 seconds. So find the minimum velocity. Just put t is equal to 1.25 back into v. So v we get negative 0.125 meters per second. That is the minimum velocity. समझ आई? 4 marks. Easy. Sketch the velocity time graph for the first 3 seconds of motion. Okay. So let's first. Okay. Again, we have the timer. So I'm just gonna end it really quickly and then please start it. So please rejoin again. Okay. Thank you. So that's for sketch the graph. This is v. Meter per second. T/seconds. So we know when t is equal to 0, if you put t is equal to 0, then we get v is equal to 3. So initial starting point is 3. Then we know that it it is 0, that t is equal to 1 is equal to 1.5. So 1, let's say this is 1.5. So and its minimum velocity is negative 1.25. And after that, at 3 seconds, velocity is six. So let's going to sketch the curve now. Going to look something like this. It's a bit sharp. The space is out of it. Oh, sorry, negative 0.125. Thank you for pointing out. This is how you would sketch the velocity time graph. This expression 1.5. Just for the smallest. Find the distance traveled between the two times when the particle is instantaneously at rest. So when particle is instantaneously at rest is basically this distance right here, right? This part of the graph. So we know the x values. So can if we will basically want the area under the graph, right? Since that's what distance is actually, we can just integrate v from 1.5. We should be getting the distance. This is easier. We can find the expression of displacement and take displacement at separate intervals, but you need to calculate c and it becomes a bit messy. This is basically the quickest way. Integrate v 2t square minus 5t plus 3. That's it, right? Yeah. From 1 to 1.5. Expression we get is 2t cube over 3 is 5t square 2, 3t are the limits. Concept is it will remain one. So get negative 0.0417 meter. Since that's a displacement, right? So since they've asked for the distance, just give the magnitude 0.0417 meter. Okay, finally, last question on the पार्टिकल पी तो ये समझ आई है ये क्वेश्चन की काइनेमेटिक्स के आईजी डी टू अंडरस्टैंड दिस क्वेश्चन इब्राहिम मोहित ब्रो
Yeah.
तो particle P of 0.3 kg rests on a rough horizontal incline at an angle theta to the horizontal where sine theta is equal to 25. Okay. This theta, sine theta is 7.5. So this will be 5 square minus 7 square under root into 4. So maybe we can find cos theta. Horizontal force of magnitude 4 Newton acting in the vertical plane containing a line of greater slope of the plane is applied to P as shown. Particles on the point of focus. This is the most important point. On the point of sliding up the plane, show that the coefficient of friction between the particle and the plane is 0. So it says that it's just about to move up the plane. So if it's about to move up the plane, that means that the friction will be acting downwards, right? So uh know that if this is the 4, let's say this is the 4 Newton acting over here, right? So and this is, let's make this vertical component. So if this force, this line is parallel to this line, and that means this will be theta, corresponding angle, right? So the uh force, the upward force is basically component uh for cos theta, yeah, it will be for cos theta. This component will be for cos theta. And its friction, since it's sliding up the point, that means that friction and its weight will uh, it will add up to cancel out the upwards component, the force. So some bit down. Not exactly. So to find the frictional force, we know frictional force equal to mu r. What will be the r? R is basically the reaction force, right? So it so what is the um component with forces acting downwards? R is basically the one which is like opposing those downward forces. So we have one we know is basically the component of gravity, which will be cos theta, mg cos theta. So R will be equals to mg cos theta plus this. There is another component of force acting downwards, which will be the component of this 4 Newton force, this 4 sine theta right here. So R will be equal to mg cos theta plus 4 sine theta. So we know that sine theta is 7/25, and we do its triangle, right angle triangle. So cos theta will be 24/7. So R is equal to m, which is 0.3 into cos 24/7 plus 4 sine theta 7/5. So R we get is 5.118. So we have the R and we have the weight component. So now let's equate. So that's 4 cos theta is equal to the frictional force plus the component of the weight. Friction force is mu R plus md sine theta. Since it's uh, sliding up the plane, so we know that mu r is equal to 4 cos theta, which is 24/7 minus md 3 sine theta. 3.3 into 10 is 3. Sine theta is basically 7/25. So mu we get is 12.8743 divided by r. So mu 2. Okay, 1 second. I think there's something wrong. Substitution with 3 or 4, right? R is hold up. Let me calculate this again. Hold up. Oh, I'm sorry. Cos is basically 24 or 25, not 24/7. So, the cos is 10. I mean, not even 10. Not even. There we go. लोग के सारे सो रहे हैं यार. So is basically तो cos को उल्टा ले रहा हूँ and you are, थोड़ी देर की बात है bro, बस आखिरी क्वेश्चन है तो सोचना। 3 यो क्वेश्चन 3। why am I taking cos 24? तो मुझे भी नींद आ रही है। वो आपका 3 है ना, खैर करेगा इंशाल्लाह। Sorry, we can now we get new with fewer for silly mistakes. They always kill us. Inshallah. Force acting horizontally is replaced by force of magnitude 4 Newton acting up the plane to land up greater slope. So basically, this force is replaced with this force right here. Find the acceleration of V. So now R will be different. So R will be just mg cos theta, which is 24, 25, 3, 2.88. So the greatest acceleration will be certain force equal to mass into acceleration. Certain force will be 4 minus ur, which is c over 4, 2.88 minus the component of the weight of the particle. So we get acceleration we get is 10 with 3 meter per second square. Starting with P at rest, the force of 4 Newton parallel to the plane acts for 3 seconds and is then removed. Find the total distance traveled until P comes to instantaneous rest. Okay. So for the first 3 seconds, it has a constant acceleration of 10 over 3, right? For T is more than equal to 3. So we can calculate the speed it like reaches at when it after 3 seconds. So we initial speed is 0, 10 over 3 is 3, Q plus 80. So at T is equal to 3. Now the 4 Newton force is removed, so we need to calculate the acceleration now, which will be downwards, right? So, so uh, so the final velocity it was v. So how much distance did it cover? Initial velocity is 0. Half then with 3 square. That's 2 like this. 15 meters for t is equal to 3. So after that, its acceleration will change since the 4 Newton imposes the most, so its acceleration will be downwards, i.e. negative mg, negative friction, which is c over 4 r 2.88 plus the component of its weight, which is mg sine theta 725 equal to 0.3 a. Quickly calculated. The relation is negative 10 meters per second square. Let's put this into the equation. The initial velocity is 15, sorry, 10. So we calculate it. And wait, let's use this 2s since we don't know the time it takes. Instantaneous rest v square is 15, sorry, 0 square. Final velocity, initial velocity is 15 square divided by 2, and acceleration is negative 10. So we get since it covers is basically 11.25. So total distance is 15 plus 11.25. So the total distance it covers until it goes in instantaneous rest is, wait, shouldn't be 11.25. Something's wrong again. Bro. 100%. Very sticky. See what the safety, man. What? Uh, Bro, smaller. Final velocity is 10, not 15. That's the difference. Yeah, I'm making so many blunders right now. Sorry. 20 meters is the correct answer. Human error. There you go. Okay, Alhamdulillah, paper is now complete. So you see, uh, we didn't have like got stuck, but if you do get stuck somewhere, please do not waste your time on it. Just move on and then come back to it later. If after coming back still cannot figure it out, just like skip it. After giving it some time, just like again skip it again, go through it again. And then if you just can't figure it out and you think you have some time, just go take a break or something to go to the washroom or drink some water. Then do that question again, and inshallah, your paper will be fine. Easy, great day start, inshallah. Uh, yep, never. Any tips on work, power, energy questions? Um, Basically, the best tip is to like, uh, just, just see what, um, like, of what's the scenario. Just imagine a scenario, like just sketch it and see what is happening. So, okay, we have a, okay, so if it's a card, like in, uh, if it's a car that's going down the hill, so basically we know its GP is decreasing. So basically that's change in energy is change in work done. So it's decreasing, so it's losing GP. Let's do that minus negative mgh. And after that, so its speed is increasing. Like this question which we did right here. You have this question. So they've told us, they've given us the masses, they've given us the angle, and they've given us the initial and final speeds, and they've also given us the work done by driving force. So we know, and they told us that there's no resistive force. So we know that change in engine work done is always like the only forces in M1. We know the only thing that's change GPE plus whatever change in KPE is equal to change in uh, work done by time force minus work done by stiff force. So basically, this is the standard equation. We just need to figure out how these are changing and with what magnitude. And they've always given us everything except one variable. Like in every question, there was always one variable missing, so we need to calculate that variable. Like over here, they hadn't given us age. Let's say they said the height is they gave us age. They gave the height, let's say it's 10, and then they tell us that uh their distance, like this x, they also gave us this height, right? This distance, this x is, let's say, 200 meters. So now they ask us to find the driving force of the car. So what we do, and the resistance is 0, so minus 0. So the driving force will be force into resistance, right? 200. And over here we will just substitute h. So you understand? Um, like they just hide one variable and they give you the rest, and just need to see what is missing and what's not. Yeah, they were always like only like they were always just like hide one variable, like in all other types of questions to find the force here. Exactly. So let's say, okay, so now let's say they gave us the force, right? They gave us that uh let's say the driving force is, let's say, 200 Newton or 2000 Newton. And then they ask us to find what will be, they give us initial speed 20, then that's what will be the speed at the bottom of the hill. So what we do is, like, let's say this is 150,000 and the age they gave us is 10. But they haven't given us final speed, so just simply we assume minus 20 square. Understand? So uh power is never found within it. Power is basically the rate of change of work done, right? Power can be found by work done, resultant force, but not by the resultant, but by the driving force. Yeah, you're right. Use the driving force, never the result. Since it's the power of the car. Yeah, exactly. And that is the driving force, not the resulting force. Any other questions? Um, and if it's like one car put in there, then they ask for driving force. Yeah. So basically that's what I said right here, right? So this car is put in the trailer, and they gave us his height, they gave us his length, and they gave us, and then they asked us to find the driving force. So basically the driving force into this length will be the work done by the driving force, which will be equal to the change in energy, which will be change in GP, which is decreasing since it's going down the hill, and the change in kinetic energy, which is increasing since the speed is increasing. That's how we find the driving force. So basically, this is the same situation. So F is the driving force. It's F right here. Yep, exactly. All the resistances, all energy and all work done. Yep. Resistance. If they didn't give us, let's say they said that the resistive force of power we pay is 100,000. So we'll add that as well. We'll decrease that from the driving force, work done by driving force. That's total work done, which will be the driving for work done by driving force minus the resistance. That is the work done by the system will be the change in energy, like work done or gained by the work and gained by the total energy gained by the system, which includes all the subtracting of GPE and addition of KE and all that stuff. But mainly there are only four constituents. Yeah, the GPE, yeah, the KE, driving force, Woden-Bertin force, and Woden resistive force. Nothing other than that, which I have seen in M1 at least. Hopefully, inshallah. All right, another. Should I end the meeting now? Yep, hopefully, inshallah.
Thank you.
फिर आपकी
Hafiz.
वर्कशॉप कब है?
5 बजे।
ए यो, एक प्लेट की वो है, हो किधर रही है ये?
लेट ही हो रही है।
अच्छा, वो
केमिस्ट्री में लेट ही हो रही
पिछली दफा तो ब्रो अब्दुल फतह bro, you came at a very good time, bro. SubhanAllah. Just ended the paper.
है।
I'll send the recording hopefully soon, inshallah. Okay, in the group. IZ, which group are you from? Okay, he left. Okay. अच्छा boys. ठीक है इब्राहिम bro. बड़ा मजा
आप
आया.
बता।
हाँ.
थैंक यू। कुछ नहीं,
तो
तुम कुछ
हम
कह रहे
जाने.
थे, मैं इसलिए कहता।
हाँ, कोई नहीं.
ओके, अल्लाह
गुड।
हाफिज।
अल्लाह हाफ़िज़। थैंक यू।
Okay, bye.